PU2 champions, welcome to day 5 of 21 days challenge to get 95% in your second PUC board exams. As part of today's challenge, I have given you 2 chapters for homework. The first one was Haloalkanes and Haloarenes from chemistry and determinants from maths. So by this time, I hope all of you have completed the challenge. If yes, let me know in the comment section day 5 completed. So if you haven't yet, do not worry. The link is there in the description section. So please click on the link, visit the page and download the most important questions PDF and practice these questions. Okay, these are very important questions. And in this video, we are going to solve the most important MCQs from the chapter Haloalkanes and Haloarenes. So let's get started and check the first question. So chlorine containing antibiotic produced by microorganisms which is very effective for the treatment of typhoid fever is. So this is chloramphenicol, option number A. Next is the halogen containing compound used as anesthetic, that is your halothane, option number D here. Next is match the following. So chloramphenicol is, as we have just discussed, for typhoid. So A is 2. Okay, I can eliminate these two options. Next, thyroxine is for goiter. So B3, eliminate this option. So correct answer is option number C here. Nomenclature of 1,1-dichloroethane. This is a geminal dihalide. The name of this one is ethylidene chloride, which is your option number A. Next is the IUPAC name of the given compound is chlorophenyl and methane. So that is your option number C. Next is vicinal dihalides are obtained from the reaction of. So if you have double bond and you are reacting it with Br2, it will give you vicinal dihalides, means the two adjacent carbons will have chlorine group. So it is alkenes with Br2, so option number B. An example of vinyl halide is, vinyl halide means when you have halogen attached to the carbon containing the double bond. Okay, so it is 1-chlorocyclohexene. So if you see the structure of 1-chlorocyclohexene, this is like this, right? So the chlorine is attached to the carbon containing the double bond. So yes, it is an example of vinyl halide. Next, same tribromobenzene is your it is your 1,3,5-tribromobenzene, means you have 1 position, then 3 position, and then 5th position. Okay. Next, an example of allyl halide. Allyl halide is like this. Okay, when you have any halogen group attached to the carbon and this carbon is attached to the double bonded carbon. So here you can see the correct answer is 3-chloropropene. If you see the structure like this, it is 3-chloropropene. So option number C here. Next, 1,2-dichloroethane is an example of 1,2-dichloroethane. So if you have like this, 1,2-dichloroethane is an example of, this is your this is your vicinal dihalides, and vicinal dihalides are also called as alkaline dihalides. Okay, so option number A. Next is again match the following with the structure. Secondary butyl chloride is your I can write 2-chloride, right? So 2-chlorobutane. So A is 4 and I can eliminate these two options. Neopentyl bromide means this is the structure of neopentyl bromide. So it is, I can say, 2,2-dimethyl bromopropane. So 1-bromo, 2,2-dimethyl propane. So B is 3. So I can see here B3, here also B is 3. Vinyl chloride, chloroethene, if you see chloroethene, right, that is vinyl chloride. So C is 1, here C is 2, here C is 1. So option number B here. Next, which of the following is an example of vicinal dihalides? Vicinal dihalides means two adjacent carbon will have the chlorine groups. Okay, so vicinal dihalides are called as 1,2-dichloroethane. If you see, this is the example of option number D. Now let's see question number 13. The total number of structural isomers possible for the compound having molecular formula C5H11Br. Okay, so if you see, I can have first 5 carbons in one ring, like one line, and that's 1 bromine position. This is 1 bromo pentane. Then you can have the second bromine on this carbon. Okay, that is 2 bromopentane, and then we can have 3 bromopentane here. Okay, then we can have 4 carbon chain and 1 carbon is present here. So this is 1 bromine, and then you can have a structure like this where you have 1 bromine here, then you can have 1 bromine here, and then we can have here 1 bromine. Sorry, this is carbon. Here I can have this bromine, right? So 1, 2 and 3, 4, 5, 6, 7. And the last one I can have is, I can have 3 carbon in one chain, and anywhere you attach the bromine, it is the same thing. So total 8 isomers we will get. Next, which among the following has a chiral carbon? Chiral carbon means that carbon which has 4 different groups. So 2-chloropropane, if you see, doesn't have all the 4 different groups. 2-chlorobutane, if you see, right? So you can see that One side it is hydrogen, one side chlorine, one side methyl, and one side ethyl. So all the 4 groups are different. So option number C here. The number of isomers possible for C4H9Br. Okay, C4H9Br. So if you see 4 carbons like this, here you can attach one bromine. Next is you can attach a bromine here. Okay, 2 positions we got. Then I can have a 3 carbon chain. Okay, in this you can attach the bromine here. You can attach then I'll do another structure. Okay, you can attach a bromine here. So total I'll get 4 isomers. So option number A here. Next, the alkyl group having the largest CX bond length. Largest, if the ion sizes or the atom size is more, the bond will also be like lengthier. So it is CH3I. The alkyne with the highest bond enthalpy. Smaller the atom, stronger is the bond, higher is the bond enthalpy. So CH3F. Alkyl compound with least dipole moment. Dipole moment depends on electronegativity. So least electronegativity means least dipole moment. So again CH3I. Compound with highest dipole moment, the more is the electronegative of the atom, more it will be, I can say, having highest dipole moment, right? So that is why CH3F. Now coming to question number 20, the best reagent used to produce pure alkyl halides is your through SOCl2 because it produces what? It produces gaseous byproducts which can easily evaporate. Next, SOCl2 replace the OH group of a compound to Cl group. The halo compound that cannot be obtained from this method is your chlorobenzene, okay? Because you cannot directly react SOCl2 with phenol to give chlorobenzene because in phenol we have partial double bond character. Aryl halides cannot be prepared from phenol because the carbon-oxygen bond in phenols has a partial double bond character. Next question 23. Good yield of Ri may be obtained by heating alcohols with sodium or potassium iodide in 95% of phosphoric acid. Next, the reaction that produces a single haloalkane in low yield. We know low yield is for free radical halogenation method. So that is free radical chlorination of alkanes. Next, free radical chlorination or bromination of alkanes is not preferred because reaction takes place in sunlight, reaction produces a single product, difficult to separate the compounds, yield of the single product is low. So both 3 and 4, which is your option number B. Next, addition of bromine to alkene in CCl4 is an important method of detection of unsaturation. The product formed in this method is your. So you get 1,2-dibromo alkane. So that is your vicinal dihalide. So option number D. Next, in Finkelstein reaction, NaX formed by the is precipitated by dry acetone and favors forward reaction. This is according to our Lee-Chatterley principle. Next, ROH plus SOCl2 will give you RCl. So that is A3. So you can have only one option, that is option number D. Here it will give you option number 4 because vicinal dihalides will form. RBr plus NaI will give you Ri. So RBr plus NaI will give you Ri and RCl plus NaOH will give you ROH. Okay, so here there is a small error. Just a minute. ROH plus SOCl2 will give you R. Okay, here also I have, okay, A will be 2, right? So this one, C is correct. A is 2, B is 4, C is 1 and D is 3. Okay, this is the correct one, sorry. Next, among the isomeric alkanes of molecular formula C5H12, identify the one that on photochemical chlorination yields a single monochloride. Okay, so if you have this 2,2-dimethyl propane, if you see the structure of this one, okay, here whichever hydrogen you replace, you will get 1-chloro 2,2-dimethyl propane only. Okay, so that is the answer which will give you monochloro product. Among the isomeric alkanes of formula C5H12, identify that one on photochemical chlorination yields 3 isomeric monochlorides. Okay, among the isomeric alkanes of molecular formula C5H12, identify the one that on photochemical chlorination yields 3 isomeric monohalcanes. So if you take N-pentane, okay, so just now we discussed the structure, the isomers of this one, right? If you take 3, that is N-pentane, 1 chlorine can come here, 1 chlorine can come here and 1 chlorine can come here. 3 different products you will get. So that is why option number A here. Next, among the isomeric alkanes of molecular formula C5H12, identify the one that on photochemical is 4 isomeric monochloride. So just now again we have discussed, if I have the structure like this, okay, then this is also carbon. Okay, if you have this also as carbon, then we have the possibility of 4 isomers actually. How? So I'll show you here. See, I'll be using a different color to show chlorine. So 1 chlorine can come here, that is one product. Then second chlorine can come here, third can come here and fourth can come here, and all these products are different. So that is what actually 2-methyl butane. Okay, so we have that one. Yes, 2-methyl butane is the correct answer. Next is the alkanes which on monochlorination produces chiral compound is. So if you monochlorinate it, it will give you chiral compound, that is butane. Okay, so if you see monochlorinate it and the chlorine comes on this position, then it is a chiral compound. Next is when an alkene reacts with component X in CCl4, reddish brown color of the component X disappears to yield a vicinal dihalide. The component X is, this is the bromine water test. So that is option number C. Next is the major product formed in this reaction. So what happens first? OH is there, HCl is there. What will happen? This one will attack on this one. And first there is a protonation. Okay, you will have a structure like this where I have CH2O plus H2. Okay, after that what will happen? Cl minus is there, it will attack on this one, OH2 will leave, and you will get a structure like this where you have CH2Cl and OH. Okay, so that is my option number B. Next, question number 35. Dry acetone is used in Finkelstein reaction because NaCl and NAB are formed is precipitated, which helps in the forward reaction according to Lee-Chatterley principle. Metallic fluorides not used in Schwarz reaction is NaF because it is an ionic compound. Next, iodination of benzene are reversible. Iodination of benzene requires the presence of a strong oxidizing agent to oxidize the HI formed. Yes, both the statements are correct here. So option number A. Select the incorrect match. Schwarz reaction CuF2 is correct. Finkelstein Ni is correct. Sandmeyer reaction Cu2Cl2 is not correct because we have Cu2Cl2. Here only CuCl2 is given. So that is 3 only, option number C. Next is a compound X with molecular formula C2H4 reacts with HBr to give the compound Y, which on further reacts with NaI and acetone to give you compound Z. Identify the compound Z. So if you see, I have C2H4, that is nothing but our ethene molecule, right? Now if you treat it with HBr, okay, so this is X. If you treat it with HBr, what you will get? CH3CH2Br. Okay, this is Y. Now if you treat this one with the NaI, then what will happen? Br will be replaced with I and you will get CH3CH2I. So that is your option number A. The correct name of the reaction Rx plus NaI gives you Ri plus Na. That is your Finkelstein reaction. The haloarene cannot be prepared from Sandmeyer reaction is C6H5F, that is fluorobenzene. A hydrocarbon C5H10 does not react with chlorine in dark but gives a single monochloro compound C5H9Cl in bright sunlight. The hydrocarbon is, okay. The hydrocarbons doesn't react with chlorine in dark but gives a single monochloro compound that should be cyclopentane. Okay, C5H911, the formula is cyclopentane. Next, replacement of disonium group by iodine does not require the presence of cuprous halide. Yes, that is correct. Iodobenzene is difficult to prepare from diazinon salt. This is wrong. So option number C, where statement 1 is correct but 2 is incorrect. Next, you have N2 plus and Cl minus Cu2Cl2 gives you chlorine plus N2. Name of the reaction is, this is Sandmeyer reaction. So option number B here. Next, again match the following. Cu2Cl2 will be Sandmeyer reaction, CuF2 is Schwarz reaction, NaI is Finkelstein reaction, sodium ether is Woods reaction. So A is 3, which option? These two are there, so I can eliminate these two. B is 1, A3, B1, so only one option is there. C is 2 and D is 4. Next is the reagent used in the Sandmeyer reaction. We have already solved many times. Cu2Cl2, option number 6. Next, gaseous halogen compounds at room temperature. So the smaller haloalkanes will be in gaseous state. So that is why it is ethyl chloride. The boiling points of the alkyl halides decrease in the order. So as the mass increases, the boiling point also increases. So here iodine, bromine, chlorine and fluorine. So option number A. Select the order of melting point. So that is para, then ortho and then meta. So option number C here. Next, 4 haloalkane compounds represented by MNOP have boiling points 24, 38, 3.56 and 101.6 degrees Celsius. Among the following compounds, N is most likely to be. Okay, so these are the options. You can see the highest boiling point will be for D, right? Because it is having more number of carbons and also it has iodine. So if you see out of the given value, P is having the highest one. So this is P. Okay. Now after this, the highest value will be for C2H5Br because here we have 2 carbons. And if you see the second highest value is 38 degrees Celsius, which is for N. So obviously the N is most likely to be option number C. Next, alkyl halides are colorless when pure. Bromides and iodides develop color when exposed to light. Both the statements are correct. So option number A here. Next, many volatile halogen compounds have sweet smell. Molecules of organic halogen compounds are generally non-polar. So this is not correct. This is definitely correct. But yes, this is incorrect. So 52 will be option number C. Next, question number 53. Statement 1. Boiling points of isomeric dihalogens are in the order of ortho, para and meta boiling point, and melting points are in the order of para, ortho and meta. Okay, so yes, this is both the statements are correct here, right? Boiling point is ortho, para and meta, and melting point is para, ortho and meta. So option number A here. Next is compound P and Q have the same molecular formula C4H9Br. Okay, compound P on reaction with aqueous KOH. So P on reaction with aqueous KOH gives a racemic mixture. Okay, it gives a racemic mixture. And compound Q on reaction with aqueous KOH, okay, gives an alcohol that reacts with Lucas reagent only on heating. Gives an alcohol which reacts only on compound P and QR. So see, if it is giving you only an alcohol which will react on heating, that means this is your primary alcohol and this must be a primary alkyl halide. Okay, so Q I can easily find out. The molecular formula is C4, that means it has to have 4 carbons. So 2-bromobutane is not possible. 1 uh, one bromopropane is here. Okay, so okay, 1 bromopropane is there, but the formula is C4H9. So 1-bromobutane can be there here. Okay, I think the only option that is possible for Q is 1-bromobutane. Then the question is if P is giving you a racemic mixture. Okay, so here's a small error. Okay, this has to be actually butane. Okay, this is a butane. So Q will be 1-bromobutane definitely, and this will be 2-bromobutane. Why not P? See, anyway, if you're getting racemic mixture, that means this will be tertiary, secondary, and then primary. It should go by SN1 mechanism. But the compound has to be optically active. It is tertiary butyl bromide, then it is not optically active. So 2-bromobutane is optically active, and this is 1-bromobutane. So option number B here. Next, para isomers of dihalobenzene have higher melting points. That is because of symmetry. So option number C here. Arrange the following compounds in the increasing order of their reactivity, increasing order of their density. So higher mass here, so 4, then 1 2 3 4. You can see here 1 chlorine, then 2 chlorine, and then 2 bromine. Next is match the following C2H5Br KCN, that will give you CN. So A will be 3, A will be 3. I have only one option here. AgCN, it will be NC, so B will be 1. C to alcoholic KOH, there will be NaOH, so there will be this one, I can say fourth option, right? Elimination reaction will happen, and with aqueous NaOH there is D2. Next, the number of atoms or groups bonded to the carbon of transition state is your 5, that is option number B. The haloalkane reacts fast with SN2 mechanism. Okay, the haloalkanes react first with SN2 mechanism is your methyl iodide, because the Ci bond can break faster. Next is the haloalkane which reacts with SN1 reaction faster is your tertiary butyl bromide. Incorrect statement among the following is enantiomers possess identical physical property. That is correct. Enantiomers only differ with respect to rotation of plane polarized. That is also correct. Enantiomers are stereoisomers which are non-superimposable. That is also correct. They are optically inactive. No, they are optically active. So D is the incorrect statement. The alkyl halide which produces racemic mixture through SN1 reaction is racemic mixture, means it has to be optically active. Tertiary butyl is not a chiral molecule. Isopropyl chloride is not there. 2-chlorobutane is there. Methyl iodide is not there. So option number C here. Okay, please don't mark this one by mistake thinking that it is the 3 degrees, so it will react fastest with SN1. It is asking you for a racemic mixture, means the reactant must be optically active. For that we need a chiral carbon. Next, the major product formed when plus 2-bromo butane reacts with aqueous NaOH. So just now we saw it will create a racemic mixture. So plus minus 2 butanol you will get. The main product obtained when alkyl halides react with AgCN is alkyl isocyanide. That is option number B. The major product formed in the following reaction is alcoholic KOH. So here there will be a double bond and that will be give you 2-butane. The major product formed when 2-bromopentane reacts with alcoholic KOH. So you have 2-bromopentane, and when it reacts with alcoholic KOH, HBr is removed, a double bond will come here, that is pent 2-ene. So option number B. Next is identify C here. So when you have dry Mg ether, so what will happen, you will get a product like this where we have MgBr. D2O, what it will do, this is plus. Okay, so D will be attached here and this is the product here. So the question is asking you about C, that is your option number B here. Okay. Next is question number. Okay, just a minute. Next is question number 68. The alkyl halide that produces equimolar mixture of dextro and levorotatory isomers of SN1 reaction is again 2-bromobutane. Just now we discussed the reactant must be optically active. Enantiomers are non-superimposable. Yes. The racemic mixture shows zero optical rotation. Yes. Both the statements are correct. So option number A. Next, synthetic halogen compounds used for the treatment of malaria is actually chloroquine. In animals, DDT is deposited in the fatty tissues. The chemical that is effectiveness against the mosquito that spreads malaria and lice is again chloroquine. Next is the chemical name of phosgene is carbonyl chloride. It is COCl2. Triiodomethane was used earlier as an antiseptic. The antiseptic properties are due to the liberation of iodine. And next is match the following. Dichloromethane, you have given chloroform. Chloroform we will form phosgene. So I know B3 is very sure. And I have only one option with that. So A will be the correct answer. You can see now other thing. A for human central nervous system. Tetrachloromethane is liver cancer. DDT is your... okay, one second. Okay, DDT is A. Chloroform. Okay, one second. A has to be 3, right? Okay, I did a small mistake again here. Sorry. Just a minute. We'll do it once again. B has to be phosgene, right? B3. Okay, I did correct. B3 C chloroform gets converted to phosgene. So A is my correct answer. Next is, yeah, DDT is for typhus, then D2, A is 4 and C is 1. Next is coming to chlorination. Okay, chlorination, we have Schwarz reaction. Schwarz reaction is for freons. So B2, okay, any one option is there only. A is chlorination, that is chlorobenzene. Beta elimination will give you alkenes, that is C4. Fittig reaction gives you biphenyl, so option number D. Next, the synthesis of alkyl fluorides is best accomplished by Schwarz reaction. The first chlorinated insecticide is DDT. The chiral molecule in the following is 2-bromobutane. Okay, you know it is a chiral because all the 4 groups are different. The stereoisomers related to each other as non-superimposable mirror images are your enantiomers. Next, let's do match the following. Alkyl halide reacts with magnesium in dry ether to produce Grignard reagent. Grignard reagent on hydrolysis with water yields you hydrocarbon. The SN1 reaction involves carbocation intermediate. The carbon-magnesium bond in Grignard reagent is covalent and polar. Haloalkanes react with KCN to form cyanides, okay, as the major product. Next, we have haloalkanes reacts with AgCN to form isocyanides as the chief product. With the increase in size and mass of the halogen atom, boiling point increases. The dash increases with the increase in the number of carbon atoms density. The catalyst used in Sandmeyer reaction is Cu2Cl2. The reaction involving in two-step mechanism is SN1. Okay. Next is the DAS reaction produces hydrocarbon with double the carbon of the haloalkanes, that is your Woods reaction. The reaction that converts bromoethane to fluoroethane is Schwarz reaction. Chlorobenzene is prepared from benzene disonium chloride using Sandmeyer reaction. In DAS reaction, bromoethane yields ethene. In dehydrohalogenation reaction, alkyl iodides are prepared by the reaction of alkyl bromides with NaI in dry acetone. The reaction is known as your Finkelstein reaction. Next, last set, the DAS reactions are generally carried out in polar protic solvents, SN1. DAS reaction allows single-step reaction mechanism, that is SN2. SN2 reactions form products with inversion of configuration. Propane 2-OL is an achiral molecule. Okay, if you see the structure of propane 2-OL, you can see that on both the sides we have methyl groups. Dehydrohalogenation of haloalkanes follow Zaitsev rule. Okay. So students, these were the most important MCQs from the chapter Haloalkanes and Haloarenes. So I hope all the questions are clear. If you have any doubt, let me know in the comment section. Thank you so much and stay tuned for the next day challenge.